I keep telling you throughout that whenever you are solving any question, or whenever I am explaining any problem or any solution to you, I always try to do the 360-degree analysis, which means that I not only just solve and explain the question, but I also talk about what are the possible variations in the question, how those variations will affect the solution, how those variations will affect the approach. All these things we keep on covering. What are the possible mistakes that you can make in a question, right? Same thing we are going to do in this question as well. This question which we are about to discuss is not a difficult question. More than 90% students can solve this question easily. Still, there are certain things in the question where if some variations are done, the question will become difficult and maybe much more students will not be able to solve or may do some silly mistake. Got it? That's what we are going to see again in this question. The question says that 3.5 kg point masses, 3 masses, point masses of 0.5 kg each are attached to a 10 mm diameter massless wire. They are attached, 3 masses are attached to a 10 mm diameter. This is the diameter. 10 mm is the diameter of a massless wire. The wire is massless. Important keyword, as shown. Whenever question says as shown, it is a good practice to look at the image, look at the diagram shown. So definitely you can see this is M is written here, here and here, which clearly means that there are 3 masses that we have. This is point mass 1, point mass 2 and point mass 3. You can see all of them are attached, are connected to a straight line which should be wire. That's what it is saying. 3 point masses attached to a wire. The diameter of the wire is known and this wire is massless. This wire does not have any mass. The wire is rotated around a vertical axis. So if this is the vertical axis and this is given, the wire is given an angular velocity omega, right? It is rotated about that vertical axis, right? So it is rotating in the horizontal plane. So we can say it is rotating about the vertical axis. Right hand thumb rule, right? Now, on a frictionless plane at 4 hertz, again important keyword, frictionless plane. It is rotating, obviously rotating needs to be done on some base. When it is being rotated, it is obviously in contact with the surface, with the base, but it is frictionless. The plane is frictionless, so there is no energy loss. We can assume that it is going to rotate at the same angular velocity omega. Its omega is not going to reduce due to energy dissipation as a result of friction because it is frictionless. Rotating at 4 hertz. It has given you the frequency of rotation as well. Choose the correct axial stress diagram in the 3 segments of the wire. There are 3 segments of the wire. If you can notice, there are 3 segments of the wire. This is segment 1, this is segment 2, this is segment 3. Correct? 3 point masses. So 1, 2 and 3 segments are there in the wire. It is saying that choose the correct axial stress diagram in the 3 sections or 3 segments of the wire as a function of radial distance from the axis of rotation. So basically these are the 4 options which are given to you in the same question. These are the part of question only. It is asking you to choose the correct axial stress diagram. So it has given you 4 different diagrams. These are axial stress diagrams. All of them on the y-axis have stress, sigma in megapascal, and on the x-axis they have radius in meter. All of them, right? And then you have different diagrams shown to you, different values, different patterns. It is asking you out of these 4, you have to choose the correct one. As I told you, this question is not difficult. Even you can solve this question without lifting pen. Without lifting pen, you can tick which one of them is correct. You don't even need to do any calculation. I will tell you how. But as I told you, we are not only going to solve this question, but we will also discuss that what will happen if the wire is not massless. Here in this question, we are not given any mass of this wire, na? Only point masses are given. Only point masses are given. But how our diagram will change, this diagram, how the diagram will change if the wire is also having some mass. and what are different things question can ask you. For example, for the same question, forget about the diagrams. Question can give you some mass of the wire. Question can give you that the wire is having a mass of 5 grams, suppose. Okay, and then it can ask you for the same setup, for the same rotation, it can give you Poisson ratio also. It can give you the value of mu also. It can give you Poisson's ratio for this wire, and then it can ask you what will be the final diameter of the midsection. Initially it is 10, no? 10 mm is the diameter entirely. What will be the final diameter of this midsection? Now the question looks slightly more complicated, right? There are more ways to increase the complicacy of this question even more. The more you will be having this confidence, you can play around with the data, you can play around with the question, and trust me, GATE questions are going to do that. They have been doing it. You need to observe it carefully. So manipulating the language, manipulating the data given in the question can present an entirely different question in front of you, which will look entirely new, but actually it is not. So all these things we are going to cover in this question. We are not just going to solve the question and tick the answer. After that, we are going to discuss lot more things. So make sure that you understand this fully till the end. Now, whenever you get a question where there are 4 options given and all 4 options have some diagrams, right? Some graph, some variation, like that. Like the question that we are discussing right now. In those cases, the solving can get very fast and easy if you observe the difference you have to observe in the 4 options, in the 4 diagram, in the 4 graph, in the 4 variations given to you. For example, suppose there is a question of strength of materials where maybe some stress variation is asked to you, okay, and 4 graphs are given to you, and in those 4 graphs, initial line is same, initial part is same, exactly same, right? But after that, one continues that, other continues at some other angle, one of them becomes horizontal, one of them becomes vertical. Suppose this is how the 4 options are framed. So in such questions, initial part you can say, clearly you can say, is same in all of them. So while trying to solve the question, never focus on the initial part, only focus on the differences and try to see if you can eliminate any option based upon the variation. If you notice, I have been sharing many tips with you and I will keep sharing that where option elimination works. You can recall, I have already discussed that in engineering mechanics, I think at 2 to 3 points, and in further topics also we will discuss that in which question option elimination will work fastest and best, right? We have discussed that. In such question also, add this one also to the list. If you have been given 4 diagrams in the option elimination can be one of the fastest way to solve, in many cases even without lifting the pen. Just like the question that we are discussing, that also without lifting the pen can be solved. If you notice the question that we are solving, all 4 diagrams are different, right? There can be a case when all 4 of them were having, suppose this is the correct option, so all 4 of them were having the exactly same shape. Suppose all 4 of them were having exactly same shapes. Only these values could have been different in all 4. Then there is no way other than actually solving and getting the option, getting the answer, right? Because by shape you cannot eliminate any of the option. By value only you have to select the right answer. So there is no other way than to actually solve the question and give the question your precious 2, 3, 4, 5 minutes. But if options are different or the shape is different, like in this one, you may choose not to look at the values. Don't bother at the values if they are same, if they are different. Just don't look at it. And try to find out which shape is going to be correct. That itself will tell you that whether this is the right answer or this one or any other. Getting the point? So that's what we are going to do in this question right now. Initially, I will not be focusing on solving it. I will assume that I am in gate and I am writing this exam as an aspirant and I want to tick the right answer and move to the next one. So I will choose the fastest way to do it, right? So what we are going to do, that we will analyze this. And if you notice, the question is asking you axial stress diagram. Basically these diagrams, these variations are variation of axial stress. The sigma is axial stress with respect to radius. What do you think could be the reason of axial stress in this wire? There is no direct load which is acting along this wire. This wire, axial direction is this one, right? This is the axial or longitudinal direction of the wire. There is no direct load which is acting along the wire. What do you think could cause this axial stress? Omega. Its rotation is going to have centrifugal effects, right? As a result of that, these masses, basically these masses are rotating, right? Centrifugal effect is not possible without mass. mr omega square. The wire itself does not have any centrifugal effect. It is massless. We will discuss the case. Once we solve this question, I will tell you that how this answer solution will change if mass was there for wire as well. But in the question, it's massless. So if mass is 0, wire itself does not have any centrifugal effect. But these masses are going to have centrifugal effect, right? These masses are at a certain radius from the center of rotation and they are rotating with an angular speed of omega. So all three of them are going to have centrifugal effects. And those centrifugal forces are going to be applied along the radius. We already know basics of mechanics. Centrifugal forces act along the radius. This is the radius. This is the length along which radius is there. So radial direction is same as axial direction, right? That's why the centrifugal force due to these masses is going to exert some axial force which will cause axial stress in this wire. Got it? So what we are going to do now, as I told you, we are going to individually analyze the effect of this mass and this mass. If I show you these three individually, what I have done, can you see? The three masses that we were having here, I have just shown them separately. This mass in one diagram, this mass in the second diagram, that mass in the third diagram. That is what I have done here. And what is this blue color, this strip of blue color representing? This is representing the centrifugal force, which is axial force here. Centrifugal force is same as axial force, I just explained. That is mr omega square. For this mass, this much is the radius, right? 0.6 meter. You can check 0.6 meter, correct? So for this mass, this much is the distance from the center of rotation. All of them are rotating at omega only and mass is m only, correct? Similarly for this much, for this mass, m, second mass, this is the second mass. What will change? Radius will change. R will become r dash, let us say. M is same for all three of them. Omega will be same because they are mounted on the same wire. So m r dash omega square. Similarly for this one, let's say m r double dash omega square. Only radius is changing. All three are having same mass, 0.5 kg. Question gave omega is same for all. So this strip is representing the value of centrifugal force, which is not going to change from center up to that mass if you consider centrifugal force only due to that mass. If I consider centrifugal force only due to this mass, centrifugal force, will it change from center to here? No. Why? Because if I cut any section here or here or here, along that line, any section I cut, this mass is on the further side of the section. So centrifugal force will be felt by that section. It's an important concept. It is an important concept that you should understand at this point of time. And I will explain this concept one more time in the further discussion. That whenever there is a rotation occurring about the center, whenever there is a rotation occurring about the center, let's take the simplest case only. The centrifugal force will definitely be felt here. But if I draw an imaginary line and if I take an imaginary section here, do you think centrifugal force will be felt here? Only look at this. Forget this question. Forget everything about this question. There's no mass, this and this, only single mass rotating about the center. This is section A, this is section B. My question is that due to this rotation of this mass at section A, there will be a centrifugal force, correct? mr omega square. But at B, will there be any centrifugal force due to this mass rotation? No. Centrifugal force, note it down if you don't know it. Centrifugal force will only be experienced between the mass and the center. It will not be experienced at any section which is after the mass. It's common sense, but it can confuse students in such questions. What does this discussion mean? It means that this centrifugal force due to this mass, it will exist between the center and this mass, which you can see from the blue strip here. But after that, it will not exist. Right? Similarly, if I talk about the second case, here, this is the mass, this is the center. The centrifugal force due to that mass, which is mr dash omega square, it will be a constant value, whether you cut here, here or here, everywhere it will be constant. Because between this point and this point, same centrifugal force will apply. R dash is defined by this point and the point where mass is located. Don't think that no sir, R will be defined by this point and the distance of the section. Some of you may have this confusion that if you have a mass rotating about the center, if at any section you want to find out how much is going to be the centrifugal force, if it is massless, don't forget, massless wire I am discussing right now. I am not considering the mass of the wire. So a wire is massless, any section I cut here, at that section centrifugal force will be mr omega square. M is the mass of this ball or point, omega is the angular velocity, r is the distance of that mass from the center. Don't think that this is going to be r, or if this is the section, this is going to be the r. Got it? So that's why between center and this mass, at any point you cut, centrifugal force is not going to change, its value will be constant. But after that mass, any section, imaginary section you choose, for that centrifugal force will be 0. It will not exist after that. Right or not? This point is very much important. This basic, it's a basic concept. It is a basic concept. But it will help you, as you can see, it's going to help you in solving the question of strength of materials. This concept, rotation, centrifugal force, will be there a lot in theory of machines as well. So point is, whatever concepts you cover in one subject, as I keep telling this, don't think that the concept is limited to that subject only. You will see the application of that concept in lot more subjects at multiple places. So here, between this point and this mass m, again there is a centrifugal force, mr omega square, for which r is this much. Constant value, wherever you cut mr omega square, this value you are going to get. And similarly, when I consider the third mass, there are three masses, right? Coming back to the question, 1, 2 and 3. So if I only consider the third mass, again there will be a constant value of centrifugal force, mr double dash omega square. This is r double dash. That constant value is represented by this strip. Right? This strip is representing that it is constant. It is not changing, right? It is not increasing or it is not decreasing, right? It is constant, constant, constant. How much is the value? This length, this is representing. Its height of this rectangle is representing this value. Constant value. Now coming to the question. What do we have in the question? Just these three masses superimpose on each other. Right? Merge all of them together. If you merge these together, the diagrams together, you will get this diagram. And whenever you are merging it, the effect of forces will also get merged. So this and this, all three will get merged like this. This, all three will get merged. This has come here, this part has come here, and this part is here. So if you merge all of them together, you have got that how the shape will look for the centrifugal force. And what is centrifugal force, bhai? I explained now. Axial stress will be caused by axial force, which is centrifugal force here. And if you have got the variation of axial force, you have got the variation of axial stress also. How? Because diameter is constant. If this is the variation of axial force, same will be the variation of axial stress if the diameter of the wire is same throughout, which is same. Question has given you 10 mm diameter for the wire. You have got the answer. Out of all these 4 options, only one option has such variation, which is option B. Without even solving, without even lifting the pen, you have got the right answer because patterns were different. Suppose in the same question, these 2 patterns were same. Suppose these 2 patterns were same, only values were different. Then also you had to solve the question, right? Because it's not KBC. 50-50 नहीं हो सकता है कि only anyone out of A or B is correct, right? So you will have to choose only one option. So yes, this method, right, just by eliminating the option, it is not sure that for every question it will work. It depends upon how the options are framed. But yes, in a good number of questions it can work. But yes, ultimately you have to do some calculation depending upon how the options are framed. But for this question, calculations are also not that difficult. Those are also very direct, very easy. Let's have a quick look at the calculation. Then we will discuss what happens when the mass of the wire is given and what more can we learn from the question. So here, what we are trying to do, that we are trying to find out individual value of force. Like this, individual forces. Only R value we will change. Only R value, right? M for individual is same. Omega for all of them is same. Correct? And yes, before coming to omega, one more point. Mass is known to us, radius is known to us. What is omega? Is omega given? Question has given you frequency in hertz, right? A common unit of frequency which tells you the occurrence of that per second. Per second, how many times is something occurring? Is some waveform repeating or some process repeating? That you can say is given by hertz. So if frequency of rotation is 4 hertz, means in 1 second, this wire is making 4 full circles. 4 times it is rotating in 1 second if frequency is 4 hertz. So 4 full rotations. 4 full rotations. 1 full rotation is 2 pi radian, right? So 4 full rotations are 8 pi radians. 8 pi radians. In 1 second. 1 second 4 rotation, 1 second 8 pi radian. So how much is omega? Omega is simply 8 pi radians per second. Simple enough? Now let us see what we are doing in this case. F1 represents the force in this section, in the first section. So as we know, in the first section, all 3 of them are going to act. In this first section, this is the first section, right? These are the three sections of the question. So in the first section, you have this and this as well as this, all 3 of them. In the second section, you have only 2. In the third section, only 1. So in the first section, force will be mr omega square due to this, plus mr omega square due to this, plus mr omega square due to this, right? That is what we are going to do here. In the first section, in this section, mr omega square, when only this is r, then mr2 omega square when r is 1.2, then mr3 omega square when this entire length is the radius. Same what we have done here, as I told you that for individual r value will be different. 0.6, 1.2, 1.8, right? 0.6, 0.6, 0.6. So 0.6, 1.2, 1.2 and then 1.8. These are the value of r for all 3 of them. So for the first section, all 3 of the values will get added. For second section, only 1.2 and 1.8 are values will get added, and here only 1.8 R value. So here if you look at it, for the first section, this mass, its centrifugal effect is also there, this mass's centrifugal effect is also there, this mass's centrifugal effect is also there. So individually m 0.6 omega square plus m 1.2 omega square plus m 1.8 omega square, all of them are there. M R1, R2, R3, right? Here it's possible that some of you will do silly mistake. You will think that R1, R2, R3, all of them are 0.6, 0.6, 0.6. I know some of you may think this, or how, but I know some of you will think that all of them are 0.6. That's why I took additional 2 minutes to again explain this funda here, right? Individual values, individual value of centrifugal force, even in this section, will not be decided by the length of this section. It will be decided by where the mass is present with respect to center, something that I already explained. So don't think that in section 1 R value will be 0.6, 0.6, 0.6, right? In this section, due to this mass, R will be 1.2 only. In this section, due to this mass, R will be 1.8, right? So for section 1, this mass is at 0.6, so 0.6. This mass is at 1.2, so 1.2. This mass is at 1.8, so 1.8. Got it? And then we added all of them together. Omega is 8 pi, as I already explained you. Just put the value, use virtual calculator and get this expression. Similarly, for section 2, if we talk about this section, now this mass is gone. As I told you, the effect of centrifugal force stays between center and the mass. Beyond that mass, there will be no centrifugal effect of that. So this mass is gone for section number 2. Only this mass and this mass will be there. Again, mr omega square due to this mass plus mr omega square due to this mass. M is same, omega is same, R is different. For this mass, R is 1.2. For this mass, R is 1.8. Added both of them together. M R omega square plus M R for that mass omega square. Put the value, omega is same, mass is 0.5. Get the value of force for the second section. Similarly, for the third section, this is not there, this is not there. In the third section, only the effect of this mass will be there, which is M 1.8 omega square. Put the value, get the answer. F1, F2, F3 you have found out. Now stress value you need to find out. Stress value, right? Stress value, as we know, is nothing but internal resistance, which will be same as this force, divided by area, cross-sectional area. Question has given you diameter is 10. Diameter is 10 mm. So radius is 5 mm. So pi 5 square. This is going to give you the cross-sectional area, radius. But this will be in mm square. Is that an issue? No. Because question has given us the force value, whatever value we are calculating, that is in Newton. All standard units we are taking, right? Meter, kg, radian per second. And if we find out the area in mm square, ultimately, if we use both these values, the stress value will directly come in megapascal, which is fine because in the diagram itself, all the values of stress are in megapascal. So there is no need to convert the cross-sectional area into standard units. You keep that in mm square, get the value in megapascal. So convert diameter to radius, pi r square or pi d square by 4. Keep the value in mm, divide the value of area. This is the value of area individually with all three of them. And you will get the value of sigma 1, sigma 2, sigma 3. Sigma 1 for first section, for second, for third. You can clearly see the value of sigma is decreasing, right? And in fact, you can match it with the options 14.476, 12.064 and 7.238. So again, by solving also we have concluded that option B is the correct option. But now comes the point, what about the situation when mass of the wire has been given to you? If wire is not massless, how are you going to solve it? Or how will this specific graph is going to change? Let us discuss that. You want to find out the effect of mass of the wire on this question. So what can we do? Let us take the wire only. What we have done? We individually took the masses, right? M1, M2, M3, and then we added, superimposed all of them. Similarly, let's separately take the wire. This is the wire only. Okay. We will see its effect and then we will superimpose, add this effect on the graph to see how the variation is going to be. Okay? Now, this is the wire, suppose in front of us. Suppose at any radius r, we have taken this section. This section we have cut in this wire at any radial distance r. Tell me, at this section, centrifugal force, or in this case you can say axial force, which will be felt at that section will be due to which mass? The mass which is inside of that section, which means the mass which is between the center and that section, or the mass which is beyond that section. Think about it. As I just told you, the effect of mass, I have discussed that, effect of mass and its centrifugal effect is not going to pass to the further section. I told here, right? Here we discussed that, right? Effect of this mass was not getting shifted to the second section. To the second section, only this and this mass's centrifugal effect were there. This mass's centrifugal effect was not existing beyond the center and this mass, right? It was not existing beyond that. So here also you can conclude from the same discussion that the centrifugal effect of these mass, which is actually a part of wire only, right? The centrifugal effect of these masses is not going to be felt at this section, right? The centrifugal effect of these masses is getting ended at this section because these masses are between the center and that section. But the centrifugal effect of any mass which is existing beyond this section will be felt. Again, to show you the same discussion that we did here. At this section, we were experiencing the centrifugal effect of this and this mass, which were beyond that section, right? So same concept we are going to apply here. At that section, centrifugal effect due to this mass which is existing beyond that section is going to be felt. Let us say that the entire length of this section is L. So this length is R, so this will be L minus R. And let us say this mass which is beyond the section is M dash, okay? So due to result of that, it is rotating, constant angular velocity omega, a centrifugal tension will be felt. Let's say this is the direction of that tension. Let's denote that with T. Got it? So this is the section that we have here. And now we are going to find out what will be the value of centrifugal force which will be felt at any given section in a case of a rod, a wire, whatever you want to call it, of mass M. Suppose M is the entire mass. M is the entire mass of this rod, wire, bar, whatever you want to call it. And M dash is only this much mass. Got it? So if we want to write M dash in terms of M, what can we do? M mass is the entire mass distributed over a length L. So mass density is M by L. Linear density of mass is M by L, mass divided by entire length, right? So this is the mass of unit length, you can say. L length has M mass, unit length has M by L mass. This much has a length of L minus R. This mass has a length, has a linear dimension L minus R. So if you multiply this with L minus R, you will get M dash. This is the mass of unit length. Multiply that with the length of this section, you will get M dash. And now, if we try to put the value of this mass to find out this value of centrifugal force, you can say. Some of you may think that, sir, centrifugal force, how you are denoting towards the center? you just need to apply the basic concept of action reaction. Okay, right now this is our focus. This is our focus. So we are using this sign to represent the centrifugal force. When you will shift your focus to this section, then the same value of centrifugal force will be denoted like this. Although this mass is not going to be used for calculation of centrifugal force, this mass is not going to be used for calculation of centrifugal force, right? Effective mass for calculation of centrifugal force is that only. But to represent that, we can choose this as a section and show that on this section this much centrifugal force will be applied, felt, which will be the same, right? So if some of you got confused that sir, how towards center we are showing T, no need to confuse. Basics of Newton's third law, action reaction. Now, the centrifugal force, as we know, is mr omega square, and this centrifugal force is due to mass m dash. So m dash r omega square. M dash expression we have found out, but what about r? Should we keep it r only? Bhai, what is r representing? R is representing the distance of this section, right? What I told you, what is r? R tells the distance between mass and the center. Mass and the center. The issue here is that mass is not a point mass, it is distributed. Mass is distributed from here up to here. In such cases, where do you consider the mass to be located? Because r is the distance of mass from the center. You will find out its center of gravity or center of mass, right? Which will be at the center, it will be here. So this is the point up to which you have to find out the distance from here. That will give you this value of r. Any idea how we can find that? We have done it now. Small r plus half of L minus r. This length from here up to this center of mass is small r plus half of L minus r. So small r plus half of L minus r. This will be the value of r here. So the two values that are required, both the values we have found out, m dash value and let's call it r dash. We have found out this, let's say, is r dash. You can even simplify it also. So it will become L plus r by 2. And omega is omega only. So if we put the value here, what we are going to get? If we put the value m, this expression, r dash omega square, m dash r dash omega square. This is centrifugal force due to this mass. M dash value we have already calculated here. Let us put that value as well. So this value of m dash, this value we have put here. If you simplify this, you will get L plus r by 2 as I have shown here, omega square. Here L minus r, L plus r is L square minus r square. And in the denominator 2L. So ultimately this is the expression that you are going to get. M L square minus r square omega square by 2L. This is the expression which is denoting that how the axial tension, axial force, centrifugal force, longitudinal force, radial force, all of the names are representing the same tension. So how this is going to vary along the length, along the radius, you can say. Please note, small r is any general radius, any general value. This small r is representing any general section. This section can be here also, here also, here also. It can be here also. Just put the value of r and you will be able to get it. And that's important. That is important to know how it will vary. Will this tension decrease or increase along the radius? Simply you can see r is with a negative sign. R increases, L square minus r square decreases. So this tension decreases. So along the radius, tension due to weight, due to mass of wire is going to decrease. It will be maximum at r is equal to 0. Here it will be maximum. Why? Because there is no mass between center and the section. Both of them have coincided. This section has coincided with the center. There is no mass between them. So all the mass is beyond the section. and the mass beyond the section applies centrifugal force, so centrifugal force is maximum. But here, when you push this section to the right side, entire mass is between center and the section. There is no mass beyond the section, so centrifugal force is 0. You will put R is equal to L here, centrifugal force will become 0. So clearly centrifugal force is highest here at the center, and here it becomes 0 due to the mass. Does the variation, let's have a look here only in this expression, does that variation is linear? Think about it. This m is constant, it is representing entire mass, L is constant, omega is constant, only R is the variable, and you can see that the relationship between T and R is not a linear, it's a parabolic relationship, you can say. So it decreases definitely, but it does not decreases in a linear fashion, right? It's a parabolic variation, you can say. So here the options that we have, here, if question gave us, suppose, the mass of wire also, then the variation is going to be slightly different than this and different than this. What will be the difference? That between these sections, between this point and this point, the value is not going to be constant. Value is not going to be constant because between these points, mass is existing, mass of wire, and mass at every section it is varying, the mass between center and the section. So there will be variation between these sections also. It is not going to be a constant. We just concluded that. We found out the expression that how this will vary. It's not constant. But it is not linear also. It is decreasing, but it is not linearly decreasing. So that variation will be parabolic. The line should be curved. It should be curved, then step, curved, then step, curved, then step. This is how the variation should be. And in this question, there are more variations possible. As I told you, question can give you the Poisson ratio for the material of wire, And since stress value is different in different section, that stress is longitudinal along the length of the wire, we'll try to shrink the diameter due to Poisson effect. Question can ask you, how much will be the change in diameter? Which section will have maximum shrinkage in diameter? How much will be that shrinkage? How much will be the final diameter? Initial was 10 only. How much will be the final diameter? A lot of things can be asked in this question, which will make this question even more complicated and interesting. So always whenever you are solving a question, don't restrict your thinking and your numerical solving abilities only just to get the answer and move to the next one. Your learning will not be maximized in that manner. You have to think about all the relevant and effective variations of the question. Now, if you will think randomly about what random variations are possible, you will waste your time. That's why it's important that whenever I am solving examples, solving problems throughout the course, you pay attention to what type of variations I am discussing. I never cross the boundary of syllabus. I never discuss irrelevant variations. Same you have to learn and apply while solving and discussing any question.